Okay, so starting again, we were talking about the P4 transistor. So the minimum dimension that actually we produced, or the minimum feature, normally we call it the minimum feature, that was present in P4 transistor is 138 nanometer. Nowadays we are actually working on 5 nanometer technology. So this was the minimum features on Pentium 4 transistor way back 1997. So almost 23 years back. So the technology has become very sophisticated now. Now we can fabricate zero point 0.5 nanometer technology, 1 nanometer technology. We are round about here. You could see the sizes of the virus, proteins, ultraviolet light, etc. The main objective again to see how small we could do fabrication with this technology. This is the brief history that how we lead towards the microfabrication and microelectromechanical systems. The first PN junction. Semiconductor. The PN junction was produced in the semiconductor, P-type semiconductor and N-type semiconductor. ठीक है आप लोगों ने already you have already studied p-type semiconductor, n-type semiconductor. They have been integrated, junction junction have been made with p-type and n-type, and it has been done in 1939. 1948 transistor. Transistor is just an electronic switch. It has been developed 1948 by J. Burdeen, W. H. Brattain, and W. Scotchley. 1954, piezoresistive effect in semiconductors was developed. Piezoresistive means when we apply pressure on the material and when its geometry changes, its resistance changes. This is known as piezoresistive effect, and it has been produced in semiconductors. 1958, first integrated circuit, IC, J.S. Kilby, it was developed. 1958 में first integrated circuit was developed. 1959, there's plenty of room at the bottom. This was the publication actually written by this guy R. Penman, and in 1959 he talked about that in the future human being would be fabricating micro and nano components, and there would be MEMS and NEMS technology. So this is a very classical publication. You could download and you could read it, that how he was thinking about this technology in 1959. 1962, silicon integrated piezo actuators were actually developed by these guys, Chipman and Long. 1965, first surface micromachined field effect transistor, FET stands for field effect transistor accelerometer, have been invented. So this was the first surface mount micromachined accelerometer was actually produced 1965. 1967 में anisotropic deep silicon etching was performed. This is a fabrication process. Anisotropic deep silicon etching. We are doing etching in the silicon wafer, and we produce deep channels or recesses in the silicon wafer, and it was developed way back 1967. 1977, silicon electrostatic accelerometer was developed by Stanford. 1979, integrated gas chromatograph was actually invented by these guys, Terry, Germain, and Angel. So if you look at the history that how we move towards MEMS, so around about 1960s, we start uh, working on the microfabrication and micro electromechanical systems. 1982, silicon as a mechanical material. Previously, before 1982, we were using silicon wafer just as a substrate. We were producing devices on top of the silicon wafer. But in 1982, this guy, K. Peterson, he used the silicon as a mechanical material in his device. 1983, the integrated pressure sensor was developed by Honeywell. Honeywell is a well-known company which is actually producing sensors. So they come up with the first integrated pressure sensor. By integrated, we mean that we have a micro sensor, and along the micro sensor, they also fabricated the relevant electronic circuitry. So it was done way back 1983. 1985, the process technology, LEGA, which is for the high aspect ratio MEMS. We would actually discuss this technology in the course. It is a German technology. It was developed by a group of German inventors. 1986, silicon wafer bonding by M. Shimbo. So how to bond two silicon wafers together? Uh, if you fabricate devices on half of the device on one silicon wafer and half of the other device on the other silicon wafer, and then you have to bond it. It has been done in 1986. 1988, beige fabricated pressure sensors were developed through wafer bonding. Nova Sensors, again it is a company. They come up with the base fabrication of pressure sensors. 1992, bulk micromachining. Screen Process Cornell. It's a company, they have developed this bulk micromachining. When we are doing machining or we are producing structures within the silicon wafer, it is known as bulk micromachining. तो ये भी हम डिटेल में इंशाल्लाह इस कोर्स में पढ़ेंगे. 1993, digital mirror display, DMD. Digital mirror display is actually used in all modern multimedia projectors, and it was invented by Texas Instruments. Again, it is a company which actually developed this DMD technology. 1994, commercial surface micro machine accelerometer was developed by Analog Devices. So the first commercial micro machine accelerometer was actually produced, and it was brought to the market by the Analog Devices way back 1994. 1999, the first optical network switch was developed by Lucent. So this is actually some brief history at how we reach and to the technology that we have today. And on this slide, you see the images of the technology which have been produced in history. So this is the first transistor. You could see the image, the first transistor. It was invented by Walter Brattain and John Burdeen, 1947. The first electrical switch. They have developed the first electrical switch, and they got the Nobel Prize for this in 1956. This is the first integrated circuit. First integrated circuit developed in 1958. and by J. Kelbag, and he got the Nobel Prize for this invention in 2000. 1997, first microprocessor. This is the first microprocessor, the modern computer. It have been invented with the microelectronic technology, or very large scale of integration. This is the very large scale of integration, and it have been done way back 1971. Uh, Up till now, some of the successful MEMS products in automobile industry, manifold air pressure sensors, airbag sensors. Airbag sensor is actually accelerometer with self test. Uh, Texas Instruments digital mirror display, that is DMD. As I told you that DMD digital micro mirrors are used in all multimedia projectors. It is used in the video projection system. However, the development cost of this system, this DMD, is $1 billion. It was $1 billion. This was the production cost. Another very well-known product, inkjet nozzles, which is actually used in the printers, laser printers, HP, Canon, Lexmark. In all those printers, we have nozzles, micro nozzles, and there are 1600 by 1600 micro nozzles, which make the resolution of 1600 by 1600. So these have micro nozzles, and those through that micro nozzles, actually the ink is injected, and we got the alphabets or letters or words on the paper. MEMS or microfabrication in the world. Most of the microfabrication is done, or MEMS fabrication is done in North America, 41%. Then Japanese are doing 12%, Germany 10%, Scandinavian countries 6%, France, Benelux countries 5%, Switzerland 4%, UK 4%, rest of Europe 3%, rest of Asia 9%, and in this 9%, mostly the countries are China, Taiwan, and South Korea. MEMS market breakdown, that where we are using those devices, or the companies are making those devices for which applications. So mostly biomedical and bio 32%, telecom 16%, in industry process control and instrumentation 16%, aeronautics and aerospace 7%, automobile 11%, defense 5%, for environmental applications 4%, home appliances 1%, IT and entertainment 8%. The popular companies and their product or devices. This is the technology area. Here you could see the typical devices or application. These are the well-known companies. This is their market baseline, but this is an old slide. This is 2003 estimation, so it is not new estimation. Just want to show you that how MEMS were emerging, and initially how companies were making money with that technology. So in inertial measurement, inertial measurements we have accelerometers, rate sensors, vibration sensors. These are the popular companies who are working, and in the market, that is their baseline in millions of dollars, 350 to 540 millions of dollars. And this is the market estimate for 2003. This is somewhat 2011 2012 report. Microfluidics and chemical testing processes. The devices in the market are gene chip, lab on the chip, chemical sensors, flow controllers, micro nozzles, micro valves, and these are the well-known companies who are producing those. Optical MEMS. In optical MEMS, we have displays, optical switches, adaptive optics, and these are the well-known companies, and that is their market share way back 2001 or 2. Pressure measurements, pressure sensors for automobile, medical, and industrial applications. And the popular companies or well-known companies who are producing that: RF technology. We have RF switches, filters, capacitors, inductors, antennas, phase shifters, scanned apertures, and these are the companies who are doing that. In others, we have actuators, micro relays, humidity sensors, data storage, strain sensors, micro satellite components, and the